Okay, so let's talk about what proportions are. Proportions are essentially equivalent ratios. And what is a ratio? A ratio is a comparison of quantities using division. So basically, a ratio is basically like a fraction. A proportion says that two ratios are equal. So essentially, this is like equivalent fractions. So give me an example of some equivalent fractions that you already know about. Yeah, 1/2 is equal to 2/4. Now here's something really cool that I'm not sure if everyone knows, but when you have two fractions that are equivalent, or two ratios that are equivalent, their cross products are equal. And the word product means multiply. So 1 times 4 is equal to 2 times 2. Is that true? 4 equals 4. That's true. So that will be true of any proportions. Anytime you say that two ratios are equivalent, then we're talking about their cross products have to be equal. And the reason why that's useful is because let's say I knew that, for example, I knew that 3/4 was going to be equivalent to something over 100. And I don't know what that something is. Well, there's a couple of different ways that we could find out what that missing number is. First of all, could you see a relationship between 4 and 100? What do you have to do to 4 to give you 100? Multiply by 25. So with an equivalent fraction, you always have to do the same thing to the numerator and denominator, right? Because you're really multiplying by the number 1. So 25 over 25, that would mean that x is what? 75. Now, if you didn't see that relationship and you just started with 3/4 is equal to something over 100, another way that you could solve that is by using the cross products principle. So you'd go 4 times that mystery number, which is 4x, is equal to 3 times 100, which is 300, and you would divide by 4, and you would end up getting, if you trust me, if you divide that 300 by 4, it's equal to 75. Or test it on your calculator if you don't believe me. Okay, and that's the reason why 3/4 is also 75 cents or 75%, right? Okay, let's think of another one. Let's say I was going to blow up a picture, and I wanted to blow it up proportionally. So I have this picture, and it's 5 inches by 3 inches. And I want to enlarge it. And all I know is that I want the width. Remember when when you drag the corner of a picture, you increase the picture's size proportionally? And I want to know, I know that my frame will allow me to have 8 inches here, but I don't know if I want to keep it in proportion. I don't know what the length is. I could write a proportion to solve for x here. So I'm comparing, it doesn't really matter which order I do this in. I can compare the width to the length, that would give me a proper fraction, or I could write the ratio of the length to the width. So I say 5 is to 3 as, now since I'm using the length up top and the width below, on my ratio for the larger rectangle, which number should go where? Should the x go in the numerator or denominator? Where should the 8 go? Yeah, the x should be where the 5 is because it's corresponding, and the 3 goes where the 8 is because those are both widths, and I'm comparing the length to the width. Now, 3 doesn't go evenly into 8, so this is where I would want to use my cross products principle. So if I cross multiply, I get 3x equals 5 times 8 is 40. And now, if I want to get x by itself, what am I going to do? Yeah, it's a one-step equation. Divide by 3. X equals, can anyone use that on their calculator? 13.3 repeating. That sounds about right. 13.3 repeating. Now, you might be asking yourself, well, that's weird because, well, first of all, how can you have repeating inches? But that's a whole other story, okay? That's weird because normally our picture frames come in 8 by 10. But you'll notice if you ever have a 3 by 5 picture enlarged to an 8 by 10, it will get cropped because the picture frame is not going to hold that. So they'll crop like 1.5 inches off so that it's still not skewed. Because if you ever take a picture and you drag it this way or you just drag it up and you don't hold the corner to drag it, right, then it will skew the picture so that it's not, you know, the length is stretching it out or the width is making it too wide like a funny mirror, you know what I mean? So that's just an example of our everyday life, but there could be multiple ways to set this up correctly so long as we have, you know, the things that we're corresponding. We have the smaller rectangle comparing it to the larger rectangle. Okay, so to solve these proportions, what we're going to do is use this strategy of cross products. Since the cross products are equal, if I know that these are two equal things, then I can cross multiply. Now, when I multiply 4 times x plus 2, I'm going to want to use parentheses. There's an implied parentheses there, and that's because both things are being divided by 5. So we're going to have 4 times x plus 2 equals 5 times 3. Or I could have just written 15. So that's the cross products, what I was talking about, the cross products principle of proportions. Essentially all equivalent fractions. So what would I do now to solve that once I cross multiply? Yeah, so I have 4x plus 8 equals 15 minus 8. 4x equals 7 divided by 4. X equals 7/4. Okay, and then we'll go ahead for our check. We can plug that back in. Now, I should show you how to do that check on the calculator because, well, this is a terminating decimal. So you could actually turn this into, how many times does 4 go into 7? Isn't it 1.75? So 1.75 if you want to use that. Because putting a fraction into a fraction, it's possible, but it just doesn't look as nice. So our check is going to be 1.75 plus 2 over 5. Is it equal to 3/4? So here we have 3.75 divided by 5. Is it equal to 3/4? And at this point, I might just go ahead and put them both in on the calculator. And you should get here 0.75 equals 0.75. And I know that because 3/4 is 0.75. Does 3.75 divide by 5 give you 0.75? Try it on your calculator. So you see what I did? I just turned it into, if it was a repeating decimal, then I would say go ahead and use a fraction. But you could still plug it in on your calculator. So let's have everybody right now try the next one. And then we will